Welcome back to Introduction to Symbolic Logic. This is Lecture 12. Today we are going to acquire a few new semantic concepts about FOL sentences. Specifically, we are going to learn what FOL validities, contradictions, and contingent sentences are. And we are going to learn when two FOL sentences are necessarily equivalent or jointly satisfiable, and we are going to discuss when given FOL sentences entail another sentence. So we are going to study and learn what all these new concepts mean, and then we are going to discuss proof strategies. And we are going to discuss how you can show that a sentence is a validity, contradiction, or contingent. And we will going to discuss how you can show that two sentences are necessarily equivalent. And then in the final two parts of the lecture, we are going to discuss how you can show that given premises entail a conclusion or do not entail a given conclusion. So that's the plan for today. A bunch of new concepts and a few new proof strategies. Let's start out by talking about FOL validities, contradictions, and contingent sentences. So let's think back all the way to the beginning of the semester. In this course, we started with a range of intuitive concepts. Specifically, we talked about necessary truths, necessary falsehoods, contingent sentences, and the intuitive notion of a valid argument. And then we tried to make these intuitive concepts formally precise. And we first introduced TFL as our first formal language, and then we moved on to FOL as our second formal language. Now, in TFL, we used the concept of a tautology to make the intuitive concept of a necessary truth formally precise. And you may recall that a tautology is a sentence that is true on every valuation. Now, our problem right now is that FOL, unlike TFL, is not truth functional. So the truth value of a TFL sentence always is a function of the truth values of its component sentences. But when it comes to quantified sentences, as we have them in FOL, this approach does not work. The truth value of a quantified sentence is not a function of the truth values of its component parts. And so we need a new approach. The definition of a tautology that we had for a TFL sentence doesn't work for an FOL sentence because for the reason that FOL is not truth functional. Now, the approach that we are going to choose for FOL makes heavy use of the notion of an FOL interpretation. And you may recall that a FOL interpretation consists of four things. First, we need to specify a domain, which is a collection of objects. Then we need to assign a truth value to each sentence letter in FOL. We need to assign exactly one object in our domain D to each name. And we need to specify which things satisfy each predicate. Depending on the predicate, this may require different things. So we need to assign a set of things in our domain to each one-place predicate. We need to assign a set of ordered pairs of things in our domain to each two-place predicate. We need to assign a set of ordered triples of things to each three-place predicate, and so on and so forth. So that's what's required to specify an FOL interpretation. Now, using this concept of an FOL interpretation, we can now define what a FOL validity is. A FOL validity simply is a FOL sentence that is true on every FOL interpretation. So for example, the sentence for all x, either x is f or x is not f, is an FOL validity. You can think of this concept of an FOL validity as the analog of a tautology. So as I just rehearsed, we started with the intuitive concept of a necessary truth, and then we used the concept of a tautology to make this concept formally precise in the context of talking about TFL. And now that we are discussing FOL, we are going to use the concept of a validity to make the intuitive concept of a necessary truth formally precise. So an FOL validity is, so to speak, the analog of a TFL tautology. Now, you need to be careful since we now have multiple words that sound very similar but mean crucially different things. A FOL validity is a sentence. Specifically, it is a sentence that is true on every FOL interpretation. Now, a valid argument is a series of sentences where one, namely the conclusion, is meant to follow from the others, which are the premises of the argument. So an FOL validity is not a valid argument. It is simply a sentence that is true on every FOL interpretation. Or put differently, some valid arguments are not FOL validities. Now, an FOL contradiction is a sentence that is false on every interpretation. So for example, the sentence, there is an X such that X is F and X is not F, is an FOL contradiction. And finally, an FOL sentence is contingent if and only if it is true on some but not on all interpretations. So for example, there's an X which is F, is an FOL sentence, and it is contingent. So for example, it is true on an interpretation whose domain doesn't contain or contains some Fs, and it is false on an interpretation whose domain doesn't contain any Fs. Okay, these are our first three new concepts: FOL validities, FOL contradictions, and FOL contingent sentences. An FOL validity is a sentence that is true on all FOL interpretations. A FOL contradiction is an FOL sentence that's false on all interpretations. And a FOL contingent sentence is a FOL sentence that is true on some but not on all interpretations.